Yeah, okay, is that on? Everyone can hear me okay? Great, okay. Well, welcome everybody. My name's David Matthews. I'm the international editor at Science Business, and I'm going to be moderating this panel on strategic or critical raw materials and circularity. So as you all probably know, for the past 10 years or so, Europe has woken up to the fact that it is pretty heavily dependent on a few certain countries, specifically China, for really key materials. So rare earth magnets, the lithium that goes into batteries, and other materials that power things like wind turbines for the green transition. And obviously we're in an era of much greater geopolitical competition, tension, supply chain disruption after the pandemic. And so suddenly we think, oh, hang on, maybe it's not such a good idea to rely entirely on other countries for our supply of these key raw materials. Now, obviously, one response to this is to open mines and process this material in Europe itself, and that's part of the EU's plan. But a really key part of it that we want to discuss today is circularity. So how do we use these materials in a way that we can recycle them, reuse them, repair, and essentially reduce the need for new material inputs into manufacturing processes. And obviously, the Critical Raw Materials Act is addressing these issues, and it's kind of currently working its way through the Brussels machinery, and we're going to be talking about that for quite a bit. So we are going to be talking for about an hour or so with our panelists, and then we'll have some time for some questions and answers afterwards, and then you'll be released and we'll have cocktails afterwards. So that is incentive, hopefully. So I will introduce our panelists. So to my left, we have Aurel Ciobanu-Dordea, who is the Director for Circular Economy at DG Environments. Welcome. My far right here, we have Ignacio Calleja, who is a Senior Advisor for Circular Economy at EIT Raw Materials. To his right is Silvestre Pinho, Professor in Mechanics and Composites at Imperial College London, who has a lot of interesting insights from the circular economy in carbon fiber and composites in the aerospace industry. So he can share some insights from something that isn't specifically raw materials, strategic more raw materials, but can give us some insights from a different industry. We also have Dario Croccolo, who is head of the Interdepartmental Center for Industrial Research in Advanced Mechanical Engineering Applications and Materials Technology at University of Bologna. And his specialism is additive manufacturing, so we can talk about that a bit later. To his left, we have Elena Gaura, who is Professor of Pervasive Computing and Director of the Research Institute for Data Sciences and Emerging Technologies, Coventry University. And your specialism is AI and monitoring and intelligent systems, which is a key part of circularity, so we can feed into that later. And to my right, we have Ana Maria Bravo, who is Director for Public Affairs at the International Flavors and Fragrances, a US firm specializing in, flavors and fragrances, and also cosmetics. And I'm hoping you can give us some insights into circularity in another area, which is the bioeconomy, and what we can learn for strategic raw materials from that. So I'll kick off, first of all, with Aurel. Can you just explain to us some of the targets for circularity in the Critical Raw Materials Act, and a couple of other EU initiatives that pertain to circularity in batteries and design and so on. So just kick us off with a sense of what the EU is planning on this.
Mm-hmm. Yeah, thank you very much, and it's very good to be here. Thanks for having me. Indeed, as you have mentioned, the concern at the level of the European Union, including the European Commission for critical raw materials, has been born more recently out of the misadventures of the supply chains that we have witnessed at the end of the COVID crisis. But of course, we have seen, even before the COVID crisis, a growing weaponization of the critical minerals by the countries which were producing them or which were processing them to a significant extent. And it has led, it's also the epitome, I would say, the best epitome, but not the only one by far, of the concept of strategic autonomy, which has been developed as a political narrative by the European Union at the end of the COVID crisis to mark the entry into a new let's say, political age at the level of the European Union. It's also the age of industrial policy, which 20, 30 years ago was a hated concept. There were people fighting to dismantle the need for industrial policy in the 80s of the last century, but this is not, however, to put an equality sign between concern for strategic autonomy and industrial policy, but there are certain connections. The initiative, which has materialized also in a legislative proposal tabled by the European Commission some time ago, and we have hopes to see it adopted by the current Parliament and by the Council of the European Union before the elections for the European Parliament, which are due in June next year. And we are optimistic about this adoption. So this has materialized in a legislative proposal which, as a grand architecture, is based on three pillars, like everything in Europe. A pillar which is mining, including remining, the use of mining waste from previous mines, which have been closed sometimes since a good number of years. But also mining, I mean opening new mines and the facilitation of permitting, which is necessary in order to accelerate the mining operations, which are famously slow in developing. The second pillar is related to the identification of politically friendly partners of the European Union, of Europe in general, in key parts of the international community, of the globe, and which are susceptible to produce significant resources from the perspective of the critical raw materials and strategic raw materials, and I will explain immediately what's the difference between the two concepts. Friend-shoring our, in a way, trade partnerships with like-minded countries so that we increase the security of supplies, because not everything can be mined in Europe. Europe is famously poor in terms of certain resources. Yes, we have found lithium in Europe, but maybe not chromium or manganese or other resources, which are also indispensable, or cobalt, for instance. And the third pillar is the pillar of circularity, because we have realized indeed that we cannot mine everything in Europe. We won't be able maybe to find enough supply, even with our friendlier partners. There are also other clients. Some of them may be able to pay as well as we do. But we need to make out the best of the existing resources. And therefore, critical and strategic raw materials which are used currently, or which will be used in key technologies helping us to achieve the green transition, the decarbonization of our economies, or the digitalization of our economies and societies, can be reused, can be recycled and reused in the future, and can be stockpiled in Europe by the member states. And we are speaking in this panel about what can we achieve by recycling critical and strategic raw materials. The proposal made by the European Commission not only establishes a list of critical raw materials and a list of strategic raw materials. The critical raw materials are, the strategic raw materials are those which we narrowly understand. I will not list them to you, but you can find them in the first two annexes to the legislative proposal. Strategic raw materials are the core, the essentials for the green transition, for instance, and for the decarbonization of our economies, for batteries, for wind farms, for heat pumps, and so on. And the critical raw materials expands on this list and adds another set of materials which are important for the production of different technologies without being so scarce, without being rare earth or something like this, but they are indispensable for the good functioning of certain technologies. And the initiative also sets 2030 benchmarks for strategic raw materials in terms of extraction, so mining. At least 10% of the EU's annual consumption should be mined within the European Union. In terms of processing, at least 40% of the EU's annual consumption should be processed in Europe. So we are speaking about the development of a sector which is not non-existent, not inexistent, but which is very limited currently. In terms of recycling, where we have some experience in general, but maybe less so in terms of strategic raw materials, at least 15% of the EU's annual consumption should be obtained from recycling. And not more than 65% of the annual consumption of each strategic raw material at any relevant stage of processing should not come by 2030 from a single third country.
Can I just jump in there? Okay, so the key target is 15% from recycled materials. Do we know what it is at the moment?
I won't be able, probably we know, I'm not that familiar with the existing figures, but I am fairly convinced that they can be found, even material specific, in the impact assessment which has underpinned the legislative proposal. But it's very variable, and I'm fairly convinced that it's in single figures. And in order to recycle, and why some have asked why is this not this target more ambitious than it looks like, because you need to take into account also the life cycle of the product where the critical raw materials are incorporated. You cannot bet that, for instance, a wind, not a wind farm, how do you call a wind mill, will last 1 year or 2 years, and you recycle it after 2 years. You can, its life cycle is much longer. The same with the batteries we are discussing. I was discussing 2 weeks ago. I attended the International Congress on Battery Recycling, and I was discussing with a number of global manufacturers telling me the fact that with the targets that we have in the batteries regulation, the ability to use the batteries at the end of their initial life cycle for secondary storage of energy is very limited, because they will have to be recycled immediately in order to meet the recycled content obligations in the battery regulation. And because I'm coming to the battery regulation, I would like to add that the Critical Raw Materials Act in itself is not enough in order to understand what is the policy and the take of the European Union, legally speaking, politically speaking, economically speaking, towards this subject matter. You need to put this in the context also of the Net Zero Industrial Act, the ambition to develop the manufacturing of such technologies also in Europe. So not only stockpiling secondary raw, critical raw materials, but also developing the manufacturing here. And you need, by itself, this will not work in the absence of sustainability, recyclability, also dismantleability requirements, which are placed in different legal frameworks which are product specific. And let me give you just 2 examples. One is actually in force since about a month. It's about the battery regulation. Indeed, you need to dovetail the battery regulation with the Critical Raw Material Act, the battery regulation, having a life cycle approach and introducing eco-design, meaning requirements concerning the reparability and the dismantling of batteries from the very beginning in order to facilitate the recycling of the critical parts in it. And the second potential reference is the legislative proposal for eco-design on sustainable products, for a regulation on eco-design for sustainable products, which was proposed in March 2022. And we also hope to have it adopted before the end of the current European Parliament, which also, I mean, magnifies in a way the life cycle approach taken under the, or epitomized by the batteries regulation. It magnifies or it scales it up at the level of all products which are placed on the European market, with the exception of food and feed, so human food and animal feed, medicines, human and animal medicines, and possibly automotive, possibly cars in particular, which is an important exemption, which was desired by some member states. We will see whether this will last until the end. So the life cycle approach taken by the eco-design regulation will pervade all the walks of or strands of industrial production, industrial manufacturing, not only industrial manufacturing in Europe, but also it will be applicable to all products which will be placed from abroad, from third country, imported from third countries on the single market of the European Union. Of course, not all of them contain critical and strategic raw materials, but some of them will contain such materials, including those on the extended list in Annex 2 to the proposal on Critical Raw Material Act.
Okay, great, thank you. That's a really, really good overview. So we've got kind of three planks there: the Critical Raw Materials Act, the Batteries Regulation, and the Eco-Design for Sustainable Development products. Sorry, yeah, okay. So yeah, in the Act, this key target is 15% of critical raw materials coming through recycling. I'd like to open this now to the panel. Do we think the Act is detailed enough, has enough money behind it to actually hit that target? Is anyone, or would anyone like to take that question?
I really think that the Critical Raw Materials Act is going in the right way. It's perfect. I don't think it's perfect. It could be improved. When we talk about money, I think that regarding recycling technologies in Europe, I think we are quite good in recycling technologies in Europe. When we talk about research, it's clear that if you check the results of the last framework programs, Horizon Europe, Horizon 2020, Framework Program 7, LIFE, KICS calls, there are many support for recycling, new recycling technologies in Europe. I think that the problem is not research per se, but it's more upscaling. Because the reality, and the reality is that many of those results from those research projects at the end are there. They are not upscale. So my point of view is that when we talk about money, I think money is needed at the higher TRL levels of technology development. And when we talk about objectives of the Critical Raw Materials Act, for me, it's clear that it's 15% recycling of the materials, but the problem could be that we have very high recycling rates of 2 or 3 specific materials, a very low recycling rates of other materials, and there is a compensation of 15%. Because there is a very interesting document from the JRC dealing with circular economy and critical raw materials, and there is a very good periodic table defining the current recycling rates of the different materials, and the reality is that the recycling rates of many critical and strategic raw materials is below 1%. And in many cases, the problem of these very low recycling rates is the complexity of the products. It's not so easy to recycle those materials from the current products. So for me, I totally agree with you, Aurel. I think for me personally, very key issue is the eco-design issue. To design from the very beginning the products with the perspective of the recycling of the future, in the future, but not only recycling, because when we talk about circular economy is much more than recycling. And this is for me another problem, is that in many cases we are linking circular economy with recycling. And for me, it's not the case. I think it could be also interesting to analyze how we can use less materials, how I can improve the reuse, the reparability, and the remanufacturing of those metals. And for me, what I really miss now is that I haven't read any good document analyzing what could be the impact of reuse, repairing, and remanufacturing in recyclability. Because if we improve reuse, if we improve reparability, if we improve remanufacturing, all those products will reach the recycling process later. So what would be the impact?
Okay, thank you. Yeah, we'll definitely get on to repair and reuse and so on, refurbishment later in the discussion. But yeah, I'll just put that point, Aurel, about higher TRL level innovation. Is there much in the Act that will go from research to actual implementation? I mean, there are sort of circularity hubs planned, right? I mean, are they going to be very, very industry and kind of implementation focused?
So your question is?
What exactly in the Act is going to turn, as you say, Europe's pretty decent research in this area into actually creating, on the ground plants where we can get beyond, below 1% recycling rates?
Well, look, I would say the following. From our perspective, based on the experience we have accumulated over the past, let's say, 20, 25 years, where this has worked in other walks of life, but it's true not in this particular one, the mere fact of establishing an obligation of recycled content, which is this 15%, should put a price tag on recycling. So should make recycling more profitable. And this in itself, I think, should stimulate the development of capacities across the member states, together with self-interest. We are not speaking about something which is imposed by Brussels. This is the echo in Brussels in collective decision-making of a concern that the member states have since years. The fact that they have a difficulty, even the big ones, and even the big industrial players have a difficulty in dealing with Congo, or in dealing with China, or in dealing with more and more countries which have seen their power leveraged by the amount of resources they control. So they change the terms of economic of contracts they conclude, they limit the access, or they prohibit simply the export of unprocessed critical raw material. So this should, there is self-interest in the member states, and they need also to be guardians of the development of this. It's not just that Brussels must control everything. Also, it would be very difficult, because you have asked also, David, about financial incentives. The EU budget represents only 1% of the gross domestic product, I think, of the European Union. Think about the fact that in the United States, the federal budget is 14-15% of this. There is a difference of scale. This means that we cannot, it is not possible to provide significant amounts of funding for all the major political priorities of the European Union. We have to fight migration. We see these days, we have to fight forest fires, we have to fight floods, we have to fight scarcity of critical raw materials. Something can be given. I think there are amounts of money available, indeed, in the research programs of the European Union, for instance, for innovation, and they are quite fertile. It's a quite fertile use of the funding, but investing as such from the budget of the European Union in developing, in scaling up these capacities for recycling or manufacturing won't be possible. And it is known, I mean, this is also what marks again the difference between Europe and the United States. We have seen in the Inflation Reduction Act in the United States, the federal, I mean, through tax breaks, the federal level has acted in a meaningful way and in an appealing way, attracting the attention of all economic operators, American and non-American. We cannot offer this at European level, and state aids are in the hands of the member states. So it's for them to play a part in the development of this. And actually, when it comes to the terms of the Critical Raw Material Act, this is based on this polycentric approach, where the stockpiling takes place in the member states and represents the whole, or constitutes the whole reserve of the European Union. We have a critical raw materials club. We are speaking about a network between member states, between the Commission and member states. So only a partnership approach can succeed in this, and not all the source of power and money can come from Brussels.
Right. Okay. Yeah. So yeah, the EU doesn't have the financial firepower of the IRA in the US, for example. So there's going to need to be a pretty strong business case for European industry to get recycling and reuse and so on off the ground. I wonder if, Dario, if I could bring you in here. Your speciality is in additive manufacturing, and I wonder if you can just give us a sense of currently, to what extent do firms actually incorporate the possibility of recycling into their design, or do we have quite a long way to go?
It's a good afternoon. It's an interesting question, this, because considering additive manufacturing, we have to consider the fact that after the end of life for this new product, additively manufactured, we needed to know exactly how to recycle them. And now, I don't know if you are aware about additive manufacturing. I guess you are, but essentially we start from the powder of the material. Now we can start from the powder of metals and build the product. So not starting from the solid and erase the material. So in this case, we can have not waste material that is erased and wasted, and also we can imagine shape that are the most different shape and optimized shape in terms of weight and material that is implied. So in terms of recyclability, it's very important new technique. But what we are going to discover, to research in this field is based on 3 points. The first is obviously the resistance, the strength of material. That must be the same of the traditional production system. The second is the design, because we must change the design. So I go further to this point, because we needed to change or rethink in designing for this new technology. And the third is the recycling of the material, because is it possible to, at the end of the product, recycle the material and produce again another product in the remanufacture the product again, starting from the powder of this component? This is the question, obviously.
But I just, how common is additive manufacturing in European industry, and maybe compared to China or the US? I mean, I'm sure you'd like to see it go further, but I just wonder where we are on the journey towards a more efficient and recyclable manufacturing process.
We are developing the additive manufacturing technique in Europe. Every country, about starting from the research activities, but not only industry are making products in additive manufacturing, not so stressed up to now, but in the future probably there will be a large diffusion of this new technology. So in my opinion, I think that we need to also to start teaching how to design, how to think about the recycling this technique, because in very short time, I guess there are lots of components that would be built in additive manufacturing and so embedded into the products. So again, the raw materials must take into account the fact that you have to recycle also this other material, and also think about how to disassemble this material at the end of the life. So there is a strong connection between the technologies, the new technologies, the teaching, the skills of the workers and the engineers. So because if you use these new technology that are very effective for the recyclability, you must use the best way you can, obviously.
Okay, that's really, but there's clearly a way to go, I guess, in European industry. Elena, can I bring you in here? We were talking just before the session on this about, we thought about the kind of lack of startups in circularity, if I had that right, which suggests that there isn't a kind of the pull factor, the demand there is kind of lacking.
I think that I'd like to rewind a little bit on the problem of raw materials more widely or more basically, and just to bring the discussion a little bit of where the society sits first and foremost in the debate. And the bottom line is we are not talking about it enough. And if we are talking about raw materials outside this fora or in the recent past, it has been with a lens of ethics and a lens of climate change. And now we are moving that lens onto the actual numbers and nuts and bolts of how do we mine them, where do we mine them from, who do we mine them with, and what do we do with these raw materials in the first place. I think overall we spoke about whole life cycle design. We are now starting to bring about whole system design and maybe start to think about whole society design of many technologies, many technological products, many of which will contain the raw materials. And those conversations are currently taking place mostly in the academe. As we heard, we have an awful lot of projects. We actually have so many mechanisms for recycling at the research base, but so very little uptake and so little opportunity for startups, particularly data-driven, AI-driven optimization startups to come and enter our supply chain of knowledge in the circular economy. So I think we do have a gap there, apart from the skills and apart from the understanding of the size of the problem or even the viable solution list, into the composition of the groups that are talking about recycling, that are talking about decomposing and end of life for the products we produce. And within that space, I think there is much to be learned from all sorts of other technologies that have taken up so far and so fast nowadays, particularly in AI around consumer electronics and consumerism of data and so on and so forth. There is absolutely no reason why we can't invest in creativity around circular economy through startups.
What's whole of society design? That's a very interesting term. Can you explain it a little bit?
I think what we see more often than not when designing new technologies and situating them is that the reason they fail, and they do fail an awful lot if we look deeply into renewable technologies, solar farms, and so on and so forth, it's uptake, utility, understanding of need, ability to maintain, and ability to use that technology to the user's advantage. So that rewinding that design process that situated those technologies in field, in the society, in the communities that they need to be used by, rewinding the process brings us to the idea that we need to consult and converse with the right segments of the society before we start the design of any new technology. And if we are talking about circular economy, if we are talking about reuse, if we are talking about buy into a new way of thinking about raw materials and the products that contain those raw materials, we've got to bring those segments of the society into the design. So bring the people and the organizations that will get on with reuse into the same supply chain and user needs specification as the people that designed the product in the first place. Don't talk about the supply chain for all the way to the production of a phone or a battery, but talk about the unified supply chain of the production, dismantling, reuse, and repurposing of the materials that are part of that chain. And all of those parts of the supply chain are operated by people. That, to me, is the society that needs to be part of the equation.
Actually, can I bring Ignacio? We spoke before the panel about education. Maybe this links to that. You think there's much more room for education about the circular economy in Europe, possibly in schools?
Yeah, everybody who knows me, come on, Ignacio talking about again is about education. I think for me, education is absolutely key issue. And when I say education, of course, I'm referring to education as we heard in the previous session at the university level. So we need more engineers, we need more chemists with knowledge about circular economy. Especially we need designers with knowledge about circular economy. But for me, it's just my personal opinion. What I think is absolutely key is to have the right education at the school level with children. And I always get the same response. But Ignacio, the children is really aware now about circular economy and recycling, and yeah, they know that they have to put this piece of plastic in the yellow bin and this piece of metal in the blue bin, but at the same time, they are asking all the time for a new mobile phone, for a new tablet, for a new video game, for a new toy, and they should know about the consequences of those decisions, and they don't know. They should know about the consequences of the materials requirements, all of these products they are asking for. So, and I think that this education at the schools will have not an impact on longer term. Of course, they will have an impact on longer term, but also a very short term, because children, for me, they are perfect catalyzers. If they are educated at the schools from this circular economy perspective, children is going to educate family in the same approach. So, yeah, I know that I repeat all the time design. I think that education at the school level, for me, is absolutely critical issue.
Sure. Okay, so there's a lopsided understanding of recycling and circularity in Europe. Yeah, we know all about recycling paper and so on, but we haven't nearly scratched the surface when it comes to mobile phones or other things with expensive element materials in them. Okay, thank you. I'd like to turn to Silvestre now. Now, your work has been with recycling carbon fiber and composites in the aerospace industry. I mean, it's not one of the materials dedicated as critical by the EU, but some of the big aerospace companies have kind of developed an ecosystem of recycling of planes and so on. Can you explain how that happened and how they did it and what challenges remain? So, because it hopefully has some lessons for what we're trying to do here with critical raw materials.
Yeah, surely. Thank you. So, so carbon fiber composites are used very extensively in aviation, and they are definitely not very easy to recycle. If you look at what has happened in the last 20 years, there's been loads of research projects dedicated to developing technologies that allow us to reclaim carbon fibers, which are extremely energy intensive to produce, and be able to eventually get a recyclate that can be used for different things, including, for instance, for additive manufacturing. And 20 years later or 15 years later, we are now at a stage where we have several plants all over the world, one in the UK, one in Germany, that are starting to try to do this commercially at large scale. So we have the technology for that, but it's not yet a success story, I don't think, because what people are finding is that now that we have the technology, we still don't have a market for these recycled composites. And this is a really big problem. So I think that there are three pieces of the puzzle missing in terms of creating that market. The first is standardization of the material. For as long as each bit of recycled material is its own thing and no one really knows how stiff it's going to be, how strong it's going to be, you cannot really analyze each batch individually. So without standardization, you really cannot progress. Another thing that you need is something like a digital passport for materials. So the recycled materials will have different properties depending on what the virgin material went through its life, whether you are manufacturing it from an aircraft that spent all its time flying or from something else. So you need those digital tools. One thing relates to education that we talked about before. Even if you have all of these and you don't have an engineering workforce which is capable of designing components with those type of materials, then you won't have products designed. And the fourth pillar, I think, relates quite a lot. I'm sorry, we have 4 pillars, not only 3. The fourth pillar relates a lot to something that was mentioned, I think, in the plenary before, and it has to do with supply chains. So we have producers of raw materials, we have companies that eventually transform those into improved value composite systems. We have companies like Airbus, which design aircraft. We have now companies that are able to recycle materials. We need companies that are able to manufacture high-value products from those recycled materials, and then we need other companies that design actual products, and we need those companies to know about each other, to get integrated, and these multi-sector circular supply chain doesn't exist yet and needs to be created.
Okay, thank you. That's really interesting. So there are plants recycling carbon fiber. It seems like it's way more advanced than lots of the raw materials we're talking about, but there's still no market. There's still no market for this recycled carbon fiber, if I have that correct.
Yes, so not a significant market. So I think that the oldest company doing recycling commercially is in the UK. They've been operating commercially for about 10 years now. In total, they've recycled about 3,000 tons of composites in their entire life. So it's growing exponentially, but definitely there is no market yet.
Okay, that's really interesting. Can I bring in you, Anna Maria? Now, you're an expert on the circularity in the bioeconomy. Can you tell us what that means? And and as in the carbon fiber circularity example, how developed that is, both maybe in the US and comparing Europe and the US?
Sure. Maybe just a few words on what the bioeconomy is. It's basically a model for an economy that uses renewable raw material instead of fossil, and thereby reducing the dependence that we have on fossil. So it's very similar to the concept that you're all familiar with as a circular economy, except that on top of that, you have the benefit of bringing renewable carbon into the loop for creating all these materials, and thereby also then reusing them, recycling them, or even degrading them into raw materials for the next generation of materials. So that's the space where my company IFF is working in. We therefore believe that by definition we are a circular, and it has been in practice for a long time for doing that. I guess my view for what I'm hearing on the critical raw materials space, which is not at all my space, there's also in our space a lot of focus on the recycling. And we shouldn't forget, as somebody said earlier, the circular economy and the circularity really needs to look at all the different steps of making the products, even starting with the raw materials and ensuring that we have a sustainable supply for that. What we've also seen that has helped the circularity of the bioeconomy is that it is a very innovation-driven sector. And while we're very happy with a lot of the innovation that the private sector, but also academia is working in this space, the policies aren't really innovation-driven enough to incentivize this innovation, to take it to other TRL levels and really get the research into really commercial products. We do have a great joint undertaking that is addressing the TRLs 6, 7, 8 and beyond, to demonstrate how we can get this bioeconomy into commercial products. But we still don't have that mindset in many of these policies that can give us the certainty for investing in these projects that take a lot of time.
Do you see a difference in approach between the US and the EU? Because your company is US based, right?
Absolutely. So referring to the U.S. Inflation Reduction Act and the executive orders that followed, this was a clear signal for the private sector on where the vision that they wanted to take. And Biden said it, we want to be able to not only innovate it in America, but also make it in America. And that then leads to all sorts of different initiatives that are focusing on, as you rightfully said, tax incentives, but also loans and grant proposals for building new infrastructures, which is something that we don't see enough of in Europe. We also have a program that is really trying to create a market pool for these products, and it's called the U.S. BioPreferred, which is it's a program that mandates the federal governments to first choose bio-based in order to stimulate the economy and get to economies of scale to really grow the sector. But in this IRA and the executive orders, they've realized that they need to make that much more accountable and with targets. Otherwise, it's easier to go for the cheapest option. I think the biggest challenge that we have in generating these sustainable sectors is that it costs more. So how do we deal with that? And here we need to provide the infrastructure to get to a certain economies of scale to then be able to benefit from that. And I think that the way the U.S. has been doing it has been quite exciting, and we would like to see a lot of that coming to Europe too.
Okay, thank you. Yeah, that's a great perspective. So a huge amount going on in the US, but yeah, this is a constant question of how do you get to economies of scale, which I'd like to return to the point about the market for how do we get an actual viable market in recycled critical raw materials in Europe? Would anyone like to address this question? I mean, because at the moment it sounds like it's always going to be cheaper to buy the primary raw material processed, perhaps mined and processed in China. So how then do you actually...
The introduction of the obligation of mandatory recycled content, for instance, in the batteries. You oblige the manufacturers to take on board recycled material, which should be made available through collection. And this offers an economic perspective to the recyclers and creates a market for secondary raw materials. And you go on and on and on concerning other technologies, and you establish the same obligations. We look, for instance, at the directive on waste electric and electronic equipment. What could be done about it in the future mandate, because certain technologies are not yet captured. Maybe not all of them would qualify under the small equipments, which are defined under the waste electric and electronic equipment directive, but a similar approach, like for batteries, could be taken in respect of this. We believe, I mean, this is an economic instrument, what we call an economic instrument under the waste management legislation, which has been proven historically effective. We are implementing it also in the packaging legislation, which is currently under adoption, and we believe that this would boost the recycling. I would like to also comment on what Silvestre has mentioned about the digital product passport, and to say that, for instance, I mean, it's not miraculous. It will still have to happen in practice, not only in the legislation, but there is now a regulatory home for a digital product passport in the Eco-Design for Sustainable Products regulation, and we are working with our colleagues in charge of information technologies in order to pilot solutions, technical solutions, practical solutions that work in reality and which could be scaled up for batteries, but not only for batteries. However, this passport will not apply to the, or we haven't yet thought, or maybe I'm not aware at least about this dimension. We think more that the DPP should accompany the brand new product and should include their information about the supply chains, for instance, the compliance with environmental and social legislation, how much recycled content is incorporated, what is it there, how it can be dismantled, the product dismantled easily, recycled, and things like this, and other informations. So this is a solution. And I would like, I'm moving away a little bit from the market, but in a way it is relevant for the market to comment something about where innovation, or what could be a priority for innovation, because I think in preparation of this panel, you have circulated a number of very helpful questions, which have been catalytic, at least for my reflection and on the way in which I prepare for this discussion. And one is about the priorities for innovation. And you have suggested a number of priorities. I would say that the priority from our perspective is how do you reduce the need, and it matches a little bit what you commented about the the layering technologies, the additive manufacturing, which reduces the need for material use. The innovation is indispensable in order to see how can we reduce our reliance on critical raw materials. Can we find, not just reduce our reliance, can we find viable alternatives to critical raw materials that we source from third jurisdictions? Can our chemical industry, which is so desperate because of the impact of energy crisis and chemical regulation, etc., be steered to produce alternatives to critical raw materials? And one additional priority is, because we are having a discussion, I don't know how familiar you are, but of course all the manufacturers of green technology and chemical industry included are very concerned, and we have tried to reassure them, because under the famous chemical legislation of the European Union, which is called REACH regulation, a number of member states have introduced a proposal for restrictions of fluoroalkyls, PFAS. So very hazardous substances which are also very resilient and very pervading. And the producers of green technologies have expressed their concerns. We need them for this, for that, for maintaining, for insulating, for keeping vacuum, for keeping humidity away, keeping dust away, and things like this, for the functioning of our technologies. So what could the innovation bring as alternatives to these PFAS? And we see innovation operating already. We have met battery innovators from Europe which have come to us to show how they are capable to produce at scale batteries for computers, for instance, and electronic devices, so arguably not yet for the bigger beasts, which no longer contain PFAS. So we would really, I mean, I think there is a lot of there are a lot of challenges here, and maybe the innovators and the scientists can show their art and their skills into this.
You want to comment on this, Anna-Marie?
Thank you. Very refreshing to hear the importance, indeed, of innovation and that we need those solutions. Indeed, from the space that we're operating in the bioeconomy, we look at the raw materials. For us, it's the biomass, and extracting from the nature of polymers, of fibers, of elements. And I can give you examples where we're reducing the need for phosphorus in animal feed, because we have these enzymes that we put in animal feed to make the processing of the nutrition for the animal much more efficient, and thereby needing less phosphorus, less emitted in the manure, and less of an environmental problem. We also are developing through innovation in biotech alternatives for lithium for batteries. And these are based on polysaccharides, simple sugar molecules that are called glucans, that have the properties of really developing some alternatives for lithium. So that's the replacement piece. But then there's another piece, which is a little bit more exciting for us, but a challenge that we're having is that industry can also even go further and develop at industrial scale nature-identical polymers and fibers and materials so that we can produce them at industrial scale, reproducibly, without contaminations that you would get through extractions. And these are some of these natural polymers that we extract from mushrooms. Now, we produce these nature identically, but unfortunately the policies don't recognize them as such, and thereby in a legislation like the Single-Use Plastics Directive, they're going to be classified as a plastic. Or they are classified as a plastic because there is no recognition for that innovation and the fact that we can make all these great products, but we need that recognition, otherwise we wouldn't invest in these types of products. So it is refreshing for you to talk about innovation. You asked to be a little bit provocative, so I think that's great, but we do have these hurdles of translating that into policies that can support the private sector for investing in that area.
Would you like to respond at all, or?
Just to say, but maybe it's less relevant for critical raw materials, that yes, we are aware of certain shortcomings in terms of plastic, and we are currently, I mean, it's a seminal period when we, of course, prepare for the next College of the Commission, which will come into power in November next year. And we think, also based on the guidance we got from the heads of state and government of the European Union in March this year, when they approved which are the priorities for a competitive Europe beyond 2030, and circularity has been identified one of the 7 strategic priorities, including an emphasis they have added on bioeconomy. So we are thinking about what are the next frontiers in terms of bioeconomy, and bioplastics is one of the things where I think we need to make some changes indeed to recognize the novelties which are brought to the market.
Okay, thank you. Before we go on to questions and answers, there's just one area we haven't really touched on. We've talked about recycling, we've talked about reduction, but we wanted to talk about repair and refurbishment as well. And Elena, I wonder if I could bring you on this. We were talking earlier, and I hadn't realized this, but you're originally from Romania, right? And there's a real culture of repair, not buying new stuff.
Well, not only am I from Romania, but I'm old enough to have lived through that culture of repair and length of life. And maybe before mentioning a little bit more about where the world was and where the world is now, I think it's important to note that we started to talk about the low-hanging fruit in realizing the act. One question that I would like to maybe explore on another occasion would be, do we really know which are all of the low-hanging fruit, and what contribution could we make straight away and directly to the targets in the Act by what we know? By reducing the use, maybe by extending the length of life of the products that first use the raw materials, and where the opportunities are. Because I don't think we have quantified those impacts that could be had pretty quickly and relatively easily. So with regards to the length of life, I think we've got 2 main avenues for extending a lifetime of a product. First is by optimizing the system, and that's to do with the engineering design. You design the whole system so that the product that is most precious, in this case a battery or wherever the raw material sits, it's exploited maximally. An awful lot of the systems that use batteries, large batteries nowadays, for example, in as storage in renewable energy sources, energy systems, will not have optimized the battery life. That can vary from 1 year in a solar system to 15 years. And it's all simply a matter of design and a matter of use, how the system is used, how the system was designed, how the system can evolve digitally in order to prolong that battery life. And then the second avenue, of course, for lengthening the life of a product is by maintaining it, by having a culture of repair. For many products where raw materials are critical, essential these days, I think that has to do with the skill, the market for repair, the ease for repair, the knowledge that things are fixable, the properties that that product will have once it's fixed. Is it going to return to full functionality? Is it going to still work just as well, be just as efficient? So in Romania, and the time I grew up there, it was much easier to repair than to replace. There was no competition on replacing because technologies were evolving at a slow enough pace for the product to still be viable and top of the range and top of function, even if it was replaced. And I think that the expected lifetime by the public was so that repairs and consecutive repairs were mandatory. You purchased a fridge, you expected it to last half of your lifetime. You bought a washing machine, you had the same expectation. You purchased a car, you expected it to be with you for the next 25 years. So expectation and skills, I think, play a critical role, and the ease of that particular avenue of repairing.
Is that culture disappearing, do you think? And
Yes,
how
very
do we
much.
get it? But how do we get it back then? Because at the moment we surely live in an economy where it's more profitable to sell you something new every couple of years rather than continuously repair it. Isn't this a more fundamental problem?
I think the culture disappeared, probably started to disintegrate, as far as I know, and I perceived it about 10 years ago, when the skills weren't there anymore. So the first thing that went away was the skill, and the second was the perceived evolution of products that was much faster. New things appear to have many more functions, many more features, desirable properties, and marketing. Yeah. So once you hit the public with new product marketing, repair becomes a little bit in the shadow, in the shade.
Okay. That's a slightly dispiriting note, because we're going backwards in that case, at least in Romania and Eastern Europe, you seem to mention.
That's my personal perspective. We have a co-patriot here, or maybe he has different perspectives. But I think it's not too late for away from consumer products. I think we are only now starting to think about how can we repair batteries, how can we bring them back to life, and we have made some progress in that market, at least as far as I know. It's not my subject area, but we are talking about cell designs. We are talking about replacing cells. We are talking about throwing away as little as we can and lengthening the life as much as we can. But I think that still remains a low-hanging fruit towards the act.
Okay, thank you. Okay, we have about 20 minutes left or so. Are there any questions from the audience? Who would like to? Yes. Okay, I think a mic is on its way to you.
But in the meanwhile, I would like to comment on, essentializing the issue. It's also a challenge, the fact that reparability is still not the most convenient avenue. It's a challenge also for taxation policy. And even if this is a hated pair of words, I think we need to reflect on how we make the price of repaired products and of repairing products and products which get their lifetime extended cheaper than buying new products. It is compatible with the ambition of the European Union to improve its resource efficiency, which is also one of the politically endorsed goals in this area.
Yes, please. Question from the audience. Could you introduce who you are first as well, please?
Sorry?
Could you just say who you are and which organization you're from?
Oh, yes.
Yeah, sure.
Oh, yes, of course. I'm Maxine. I'm from Cube Energy, a Chinese manufacturer for battery energy storage systems for large-scale projects, including C&I and utilities. So I came from Switzerland, and I got a client there saying the EU is pushing through a new policy about recycling. The importer would have the responsibility to recycle the batteries. Is that an idea, or is that actually happening? And I'd like to know your comments on this. Thank you.
markets?
Sorry, I haven't. Could you repeat the question just?
I'm saying I have clients in Switzerland. They're saying it's happening. They're saying it's happening in the EU. An importer of a battery system would have the responsibility to recycle the batteries in the end. Is that happening?
Yes, it is a carrier of the extended producer responsibility. The extended producer responsibility, which is also a standard, let's say, policy used across the European Union since decades in respect of other products, is becoming applicable with the batteries regulation also to the batteries which are imported in Europe, and who can, obviously, it's more difficult, it's more practically cumbersome to make the manufacturer from China or from the United States or from Japan or from South Korea carry the burden of this. It's also a little bit illogical. So we are making the extended producer responsibility applicable to the primary importer which places a product on the market. So this means that importer we have to take back, recycle, etc., or carry the duties of extended producer responsibility.
Okay, thank you.
So it is true.
Okay.
In a nutshell.
It's happening in every country in Europe now.
Yes, it should happen all over Europe.
Just that I haven't seen enough facilities and the private businesses engaging themselves in recycling batteries. So is there any incentive or subsidies from the government to help
They prepare for, so the regulation has entered into force about a month ago, a little bit more than a month ago, and they are preparing. I mean, the big manufacturers, at least we know for sure because we have discussed with them, they prepare for this. Subsidies, I'm not aware. Certainly, they must be more modest than those applied in China.
Thank you.
Thank you. Anyone else? Anyone else like to pose a question to our panel? If not, I can jump in with one of my own, but sorry, one over there. Yeah.
Hi, thanks. That was a really interesting discussion. My name is Deirdre Cadden from the Advanced Materials and Bioengineering Research Centre in Trinity College in Dublin. I just want to ask about the Critical Raw Materials Act's requirement to have 10% of strategic raw materials mined. Do you see that this is actually achievable in member states, and do you think the public has an appetite for opening mines?
Well,
controversial, sorry.
It's difficult. It's difficult to say. It's an ambition. We will have to look closely at this as the implementation will unfold over the next few years. And would it prove to be overambitious? I think there will be grounds to revise this. But for the moment, I think it's an ambition which needs to be taken into account and made operational. There are also possibilities. There are some possibilities in Europe. I mean, there are some resources which are underexploited. There are resources also which lie in the mountains of mining waste which we have accumulated in Europe over 50, 60, 7 years and which are still exploitable.
Does that answer your question? Is that okay? Great. Thanks. Interesting question. Yes, another question over here.
Hello, my name is Marek Simon. I'm a national contact point for digital industrial technologies in Horizon Europe. My question regards these digital product passes which have been mentioned. As I understand, they are not yet mandatory, right? But can you maybe give an estimate of when these product passes might come into become a part of mandatory regulation?
They are mandatory under the, it is mandatory under the batteries regulation, which is actually even before the ESPR, the home of digital product passport. So when the idea came to our mind, we put it already in the batteries regulation because that was a political priority, to have the batteries regulation proposed and adopted. So it is mandatory for batteries. It will become operational also for, let's say, textiles or other, or for, I mean, maybe it's not good example, steel or aluminum or things like this, but for other products, once we will adopt the individual acts under the regulation on eco-design for sustainable products. So those of you who are a little bit familiar with this regulation would have noticed that it's in a way a framework, not an empty shell, but a framework enabling the Commission and the Member States and the European Parliament to pass, essentially the Commission, but under a certain political supervision, to adopt individual implementing acts concerning textiles, steel, aluminium, glass, I don't know, polymers, plastic, tires, etc., establishing the sustainability criteria, but not only, the conditions for digital product passport, the mandatory recycled content, if you think about plastic, for instance, or textiles, the reparability conditions, the, I don't know, other horizontal elements. So it will, we are still pondering whether we should adopt this as maybe as a horizontal act, as this is also possible, to lay down conditions which are horizontally applicable under the regulation to all products. So the digital product passport must meet the following characteristics, contain the following information, be provided by the following economic operators and things like this. So it is more likely maybe to see such an intervention, which will be mirrored afterwards in the acts concerning individual products.
Thank you. That's a very interesting explanation. Did that make sense? Okay, great. Sorry, you wanted to come in, Anne-Marie. Yeah.
I just wanted to comment because I am familiar with the eco-design ESPR regulation and the digital passports. I think it's great and hopefully it will give consumers clarity on what to choose versus not choose, with good explanation, and green claims will also play a big role. I think from where we're sitting and we're looking at all these regulations, it goes back to my key message here, which is this plea for opening the vision of what innovation is bringing to the table as part of these solutions. What I mean by that is that we need to be able to classify by looking at the life cycle of the entire product, whether it came from a fossil source, whether it was recyclable, whether it was sustainably extracted, if there was some effort to find an alternative or some innovation, because I think the way we're looking at some of these, and I have an example of enzymes which are classified as respiratory sensitizers and are going to be labeled in a certain way, but they are bringing so much sustainability benefits that are not accounted for in how these products are going to be labeled, whether it's in a passport or in the eco-design criteria. So my plea would be that we do look at this in a more holistic way, looking at the entire sustainability attributes that a substance can bring, whether it's a raw material or a specific substance at one point, because otherwise we're missing the complete picture and we're looking at things in a very simplistic way. Innovation is going to continue to provide alternatives, and we need to take into account that.
I agree with you. I mean, you make a formal plea, for instance, for this information to be available, and I can say that it will be retrieved in the digital product passport. But actually, your plea is for taking a balanced approach between the limitations or constraints or undesirable effects of certain ingredients and their benefits, and to strike a fair balance between advantages and disadvantages, and to be more open with the risks. This is what you mean, coming from the United States, where the regulatory philosophy in terms of chemicals is a little bit different than in Europe. Yeah, we are this is a topic of active reflection. It is clear that we need, and again, the example of PFAS comes to mind, or the example of lithium in batteries, which has been labeled as a hazardous substance by the, or deemed as a hazardous substance by the Chemicals Agency of the European Union, ECHA, and this the Commission will have to follow up on this. It will entail only labeling consequences, and some consequences for the manufacturers will have to take measures for the protection of workers. So the consumers will not be concerned about this. But of course, the chemical industry is concerned about all these restrictions. And our message here, I mean, it's a little bit general, and we will have to specify to make it work in each case for each category of PFAS substances, or for lithiums, or for siloxanes. For instance, the Commission, and I think the European Union at large, are committed to make sure that we strike the fair balance between the need to protect consumers and workers and need to allow essential uses which are essential for our economies and societies, without which the green or the digital transition of our economies and societies would not be possible. And we will make this happen. On PFAS, probably in 2025 will be a crucial year, because we will be invested, the Commission will be invested by the evaluation of the Chemicals Agency, and then we will see how we can proceed. We hear the calls of the industry to give priority to the clarification of the situation of those PFAS which are used in industrial manufacturing, so for solar panels, for heat pumps, for batteries, etc. We hear also the call of consumers, and consumer uses are different, to take the necessary measure to protect them under the undesirable effect of PFAS there. We will try to be as quick as possible in order to offer both industry and consumers the necessary guarantee. So we hear your call. It's a fine, I mean, of course, this is a generic approach again, and the proof of the pudding will be in eating the pudding. So you will have to watch us, what we will do with them in the next 3-4 years. A minefield.
Thank you. Any more questions in the audience? Okay, in which case, before we go, we only have a little while longer. I would like to pose one final, maybe slightly awkward question, which is, what do we do if there is a conflict, potentially, or a trade-off between circularity and other green goals like emissions? So if you design a product to be more recyclable, it might be slightly less efficient, which might increase emissions over the long term. And the reason I'm asking is a conversation we had, Silvestre, from the aerospace industry, where I think the aerospace industry would kind of argue against circularity in some aspects of plane design. Is this right? So that, because otherwise emissions for planes will go up. I wonder if you could explain a bit more.
Yeah, sure. So suppose that, for instance, in aviation, we had currently the same recyclability targets that we have in automotive, say 85% must be recyclable. That is actually achievable nowadays with aircraft such as the Airbus A320. We can recycle 85% of them. That's not a problem. But the reason we can recycle them is because they are mostly metallic aircraft. They're made of aluminium. If you look at more recent aircraft, like the Airbus A350, which is made mostly of carbon fiber composites, it's much lighter, much more energy efficient, but currently there is no market for recycling it. We have an emergent technology for recycling it, but if, for instance, Airbus had to demonstrate that it can now recycle all of its aircraft, it couldn't. So the contradiction here lies in that if we were to mandate a recyclability target of 85%, we would be effectively requiring aircraft at the moment to be made out of metal. But if we were to do a life cycle analysis of a metal aircraft versus a composite one, so with a composite one, you have to manufacture carbon fibers from organic material with a lot of energy, but then flying 1 kilogram of material takes a lot of energy of burnt fuel. So you actually have a better balance if you make your carbon fibers, fly your lighter aircraft, and then landfill it at the end, than if you do it with a metallic aircraft and recycle it at the end. So I guess, to my mind, the key message here is that recyclability targets need to be informed by life cycle analysis and be specific to materials and sectors.
And tailored to the characteristic of each product. There is no single delineation or delimitation border between recyclability and other, let's say, public policy interests, but it has to be fixed depending on the characteristics of each product or categories of products. And this is the role of the impact assessment. As for the case of PFAS, the opinion that we are waiting from ECA in 2025 will be the impact assessment saying this is indispensable, this is dispensable, this has alternatives, this has no alternatives known yet. We will be obliged under the ESPR, under the Regulation on Eco-Design for Sustainable Products, when we come with the sustainability criteria for polymers or for textile or for steel, to perform in each case an impact assessment saying the current sustainability criteria or the mandatory recycled content here is justified to be at 30% in this case, but at 15% in that case, because, and we need to fill in the data. What does the manufacturing experience say, what stocks say, etc., emissions, and so on and so on. So it's a variable, I mean, it's a balance to be struck continuously for each category of product.
If I could just comment on the continuously word, I think it's quite a key one, because, for instance, if we have a recyclability target in, say, aircraft, for instance, in the future, if we had a very large recyclability target, say, 10 years ago or 15 years ago, it would have killed completely the projects like the Pervasive 350, which is mostly composite. But if we have one perhaps in 5 years' time, as the recycling industry increases, it can actually catalyze that industry. So the timing is actually something very important there.
Yeah. It's part of the solution or the approach.
Yeah. Thank you. Fascinating. Would anyone else like to come on this?
This should be the passport for heavy recycling products, also for the technology of the future, because in the future we will have new technologies such as additive manufacturing, but there will be the need of having something that to take into account everything of recyclability and consumption. So, in my opinion.
I think it's the nature of wicked problems that they intersect, and unless we understand that intersection space really, really well, we are never going to do optimally across a number of stretched targets in so many sectors. And I think that the academe has a very important role to play there. I think we need to be the conveners of those debates that don't just talk about one area of targets, one act, but also the impact of solutions within that one act to the other act and the other act. And we started to develop a habit of talking across disciplines and across sectors in the academe. We now need to bring into that debate the other arms, the policy arm, the funders, the society, the industry, and so forth. So I do feel very much that the more we express what the wicked problems are that we are facing today, the more we evolve as academics in our roles to convene, to debate, to innovate, to invent, and then to translate those innovations into societal impact. I think we do have yet a big role to play, even if a lot of technologies for recycling, for example, have been developed and are waiting scale up. We have much work to do for those intersections between sectors, at least.
Okay. Sorry, last moment.
Just one final comment. I think indeed the challenge that you as Commission have is to regulate or develop a policy that keeps up with the fast speed of innovation across so many sectors. And it is a huge challenge. And yes, you do public consultations and we provide feedback, but I think there isn't enough reflection on where we can provide you a sort of update on how innovation is moving in some critical areas, to indeed not have a corrective measure afterwards in policy, but a much more co-creation of policy where you're really hearing the perspective of academia, of industry, where the innovation is going, because in all areas it's going very fast. I could talk about biotechnology and GMOs and how fast that's going. There's so many different spaces. So it's a challenge, and I wonder how better we can do to have an exchange, to really have a collaboration in shaping policy.
Any last thoughts, Ignacio, from your end, or should we run to the cocktails?
Sorry?
Any last thoughts from your end, or should we?
Yeah,
should we?
For my side, I think just to repeat that, as for example, your example, in the Additive raw materials, we have a lot of links with startups dealing with development of new industrial technologies. And I think most of them, I would say the majority of them, are looking for the improved efficiency of those technologies. They don't consider these recyclability aspects when they design the technology. So once the technology is there, we will see in the future how this could be recycled or not. So I think that this recyclability aspect should be considered from the very beginning, is my opinion. And regarding innovation, I think that the Commission, with the new approach of this emerging techniques chapter of the best available technique reference documents in the Industrial Emissions Directive, is going to really help a lot industrial innovation in Europe. I think the real in-depth analysis of emerging techniques for the different industrial sectors to be seriously considered in these documents, for me, personally, I think that this is going to be a big step in supporting innovation in Europe. Yeah.
Okay, thank you. We'll leave it there. Thank you very much for being with us. Some really interesting questions. So to remind you, tomorrow the conference continues with a discussion on sustainable aviation and green capital. And then before lunch, we have a kind of final plenary about how to translate everything we've discussed into actual EU policy. But for now, there's cocktails in the atrium for more mingling. And finally, would you please give the panel members a round of applause for their excellent contributions? Thank you very much.